Welcome back. Now, in a previous lecture, we've already had a look at the core functions and features of AWS Lambda. In this lecture, I want to take you through a demonstration and an exercise where you can see the actual power that AWS Lambda offers AWS customers. We'll also be looking at another service, the AWS EventBridge service, which we discuss in a lot more detail in the application integration section of this course. Okay, so I want to take a look at a typical use case. As you're building applications for your business, you generally will need to go through different environments and stages of your application development lifecycle. So you're going to have the development stage, the testing stage, and obviously the production stage where you release the application to the end user or customer. Specifically for the purposes of this exercise, I want to focus our attention on the testing phase of that application lifecycle development. The test phase will usually comprise of allocating some amount of time, and this could be a matter of days, weeks, or even months, to complete all of your alpha and beta tests. Once your application has passed the test phase, you can go ahead and release it into production. Now, when it comes to testing your application, obviously you're going to need to provision resources in order to complete the tests, whether those are alpha tests or beta tests. And for this, you will need to launch and configure test servers ready for the user acceptance testing test team, the UAT test team, to carry out all the necessary alpha and beta tests. In addition, you probably will want to deploy on-demand EC2 instances, configure OSs, and deploy your application on those instances. Now, the reason why we're going with on-demand EC2 instances is because obviously the life cycle of this phase, the UAT test phase, is temporary. It may last, as I said earlier, a few days to a few weeks and maximum a few months. So you certainly wouldn't want to deploy reserved instances for this scenario. So let's assume for the purposes of this use case that we will need the test phase to last up to 3 months. Within 3 months, our testers will perform all of the user acceptance testing that's required to release the application into production. In most cases, the user acceptance testing team will work standard Monday to Friday, 9 a.m. to 5 p.m., come in, create all of their tests, run them, and work out whether or not the application meets the requirements as stipulated by the business. Now, in most cases, when you're running on-demand EC2 instances, you are charged on a per hourly rate. This also means that if you let those servers run overnight and at weekends, then there's an unnecessary cost that you have to bear. So what we would like to do is obviously ensure that those servers are only available when required. In other words, they're switched on in the morning before 9 a.m. before your testers come into work, and then switched off again after 5 p.m. after the testers leave for the end of the day. And obviously they remain in that switched off state over the weekends. Now you could perform this exercise every day manually, switching them on in the morning and then turning them off again, after work. Imagine if you have hundreds of these test servers. It's going to be a real difficult task to perform, an additional management overhead that you need to take care of. What's more, imagine having one of your junior engineers perform this task day in and day out. They're going to get seriously bored. So we need to come up with a solution, a proposed solution to set up a schedule event to automatically stop your EC2 instances at the end of each weekday and then restart them up again just before at the start of each weekday. Now we want to automate this process so that you don't have some poor individual sitting down performing this task manually day in and day out. So here we have the proposed architecture. You've got your UAT servers, your test servers sitting in a VPC somewhere within the AWS cloud. Okay. In addition to that, you also will need to make use of 2 additional services, AWS Lambda and EventBridge. Now, AWS Lambda will contain the necessary function in order to stop and start your EC2 instances. AWS EventBridge essentially is going to help you trigger those functions at the designated time slots. And so at precisely 9 a.m., the event rule will trigger the Lambda function to switch on those servers. And then at 5 p.m., another event rule will trigger the Lambda function to stop your EC2 instances. We actually have the single Lambda function which carries both capabilities, the ability to start and stop your EC2 instances. And I'll explain this in more detail when we get on into the lab and show you the actual Lambda function code. So let's take a look at the lab implementation steps. Step 1 is you will need your EC2 instances to be deployed and, more importantly, tagged correctly. Tagging is going to be absolutely vital for this exercise. Now I've tagged my EC2 instances, which I'll show you in the lab in a moment, with a name of project and a value of UAT. And this is imperative. Next, you're going to have to create an IAM policy and an IAM role to allow Lambda to access your EC2 instances with the necessary permissions to start and stop those EC2 instances. In step 3, we'll create a Lambda function which will be configured with a piece of code that will allow you to start and stop your EC2 instances. And in step 4, we will configure an EventBridge scheduled event to trigger the Lambda function at the designated schedule to perform the start and stop of your EC2 instances. Right, let's jump on into the lab and see how this all works. Okay, so here we are in our AWS development account. I'm in the North Virginia region, and essentially I've already deployed some EC2 instances as preparation from the lab. In order to complete this lab, you will need to deploy at least one EC2 instance. I've deployed 3 just for the sake of illustration. So I've got 2 test servers, Vegan Test Server 1 and Vegan Test Server 2, and I've also got a production server. And I wanted to illustrate how we have differentiated between these servers. Obviously the names are different, but more specifically, if you look at the tags for my test server 1, so there's the name, Vegan Test SRV 001. But I've also included a tag with the name of project and a value of UAT. Now this element is critical in identifying which servers I'm going to start and stop at those designated time slots. If you take a look at my production server and I look at the tags, you will notice a key difference there. So the project key for my production server, the value is set to prod. So this means that the Lambda function that's going to be used in order to trigger the start and stop of the EC2 instances shouldn't affect this server. Okay, right, let's move on to step 2, which is to create a IAM policy and an IAM role to allow Lambda to access our EC2 instances with the necessary permissions to stop and start those EC2 instances. So for that, we need to go to IAM, and I'm just literally going to open that up in a new tab. And the first thing that we need to do is create a policy, and then we'll be creating a role with that policy attached to it. So if I go into policies and click on create policy, click on the JSON tab, and you need to copy and paste the policy that's provided to you in the resources section of this course, or alternatively in our GitHub repository, the link of which is available again in the resources section of this course. So I'm just going to paste in the policy there. Okay, and there we are. This is the policy. So just to run through what this policy will do, this policy will allow us to create a role that will allow Lambda to effectively perform certain actions on our EC2 instances, as well as within CloudWatch. Okay, so I'm going to click next, click review, and we'll just give it a name. So I'm going to quickly call this one Lambda EC2 policy. Okay, so I know what it is, and click create policy. And that creates the policy for us, which we're going to use in order to configure the role. Okay, so the next thing that we need to do is create the role. So I'll click on roles, and obviously the role that we're going to create is for Lambda. So create a new role. So the trusted entity is going to be for an AWS service. It's going to be AWS Lambda. Click next. And we're going to select our Lambda EC2 policy that we just created a few moments ago. Okay, go ahead and click next again. Give it a name. So I'm going to call this one Lambda EC2 start stop role. So we know exactly what it is. Okay, and then go ahead and click create role. So that's the Lambda execution role that's been created, which will be used when we configure the Lambda function. Okay, so the next step is to go ahead and create the actual Lambda function. So we need to navigate to the Lambda management console. And I'll just open that up in another tab. And what we need to do is click create function. And we're going to author from scratch and give it a function name. So I'm going to call this one Lambda EC2 start stop function. Okay, fairly self-explanatory. Now the sample code that we're providing you for the function is written in Python. So we're going to use Python 3.9, the latest one. It's an x86 64 architecture. And obviously this is where you're going to attach the permission that we defined in the role. So you're going to change the role to use an existing role and select the role that we just set up a few moments ago. So that's the Lambda EC2 start stop role. Okay, and everything else, to be honest, you can leave it as it is and go ahead and click create function. Okay, so that's our function created. And now what we need to do is to basically add the actual Lambda function code that was written in Python. So let me just bring up my Visual Studio where I've got a copy of the code. And again, the code is available in the resources section of this course or on our GitHub repository. Okay, so this is our Lambda function. Now, I just want to run through a couple of key points of this Lambda function. So in our Lambda function, we've got two key areas that I want to highlight. The first is the default tags, which is basically a set of tagging information that's obtained from the environmental variables that we will be defining in our Lambda function. And I'll show you this in a moment. The second is the actual Lambda handler. Now the Lambda handler will take the job of starting and stopping your EC2 instances with specific tags. Okay, so in order to trigger the Lambda function, you would need to supply the action that you want to perform as well as some tag parameters. And if the tag parameters are not supplied, then the Lambda function will make use of the default tag information, again, which I'll show you in a second. But essentially, there are two key actions that can be performed by this Lambda function: a start action and a stop action. And depending on the action that you request as part of your trigger to the Lambda function, the Lambda function will actually either start your EC2 instances or stop your EC2 instances, again, focusing only on those EC2 instances that meet the tag parameter, okay, or the default tags. So the first thing we need to do is copy this Lambda code and paste it in our Lambda function. And there it is. Okay, so it's all in there. And then the next thing is to click deploy. Okay, so we've deployed our Lambda function. Next, you want to go into configuration and then down to environmental variables, click edit, and we'll be creating two separate environmental variables. So click add environmental variable. The first one is going to be default underscore tags. And we need to put in the tag information here. So it's going to be tag colon what the name of the tag is. So it's project in our case, and that is equal to the value of UAT. So if you remember from the EC2 section, if I just take you back, this is the EC2 section. This is one of our test servers. The key for the tag is project and the value is UAT. And so that's how we are setting our environmental variables accordingly. The next environmental variable to create is a log level, log underscore level. And we'll just set that to info for now. We just need information retrieved and click save. Okay, so we've got our default tags in place and we've got our Lambda function in place. And a couple of things that I want to do very quickly in terms of the configuration is also just reset the timeout value. So I'd like to set the timeout value to 10 seconds, just in case takes a bit of time to initiate and we don't want it to time out. Okay, right. Okay, so we have our Lambda function in place. We have our configuration with our environmental variables defined, and we've set the timeout to 10 seconds. The next thing that we really need to do now is to actually test our Lambda function. So if you click on test, we'll create a new test case. Okay, and I'm going to call this one my Lambda EC2 test. Okay, and this is where you need to provide the JSON of the actual test case, okay, of what you want to test. And at this point in time, if we take a look at our EC2 instances, they're all in the running state. So probably a test would be to see whether Lambda can stop those EC2 instances. So I'm just going to change the values here very quickly. And remember, it's the action that we need to define. So action colon. So we're going to test if we can stop the EC2 instances. So stop is our action statement, and that is it really. So we'll save the test event and then click on the test button. And as you can see, we've got an execution result of succeeded. If we take a look at that for a second, you will see that the event was action to stop our EC2 instances. And the EC2 instances that have actually been stopped have been identified by the default tags we define in the environmental variables, specifically the tags with the value of UAT. Okay, so it's gone ahead and stopped these two EC2 instances. And if we actually go back to the EC2 management console and just refresh that page, you will see that those two instances are now stopped. Fantastic. It actually works. And I hope you are rejoicing with the fact that you are able to now automate your start and stop of your EC2 instances. What I'd like to do next is actually run another quick test. Remember, we've still got one server running, which is the production server. Okay, this has got a tag with the name of project and the value of prod. Now you were clearly able to see that, when we ran the Lambda function, it didn't affect this server. This server is still in the running state. But what if I had a change of heart? What if I needed to stop a set of other servers? Could you use the same Lambda function to do so and trigger it from perhaps a different service? Absolutely. So let's go back into the Lambda function where we have our test, and I'm quickly going to make a change to the actual test event. So we've got action stop. I'm going to put a comma after that and put in another line in there. And this time we're going to identify a different tag, a tag that's going to override the default tags that we've specified in our environmental variables. So we've got tags, and we'll do a colon and a space. And this time we need to define the tag itself. So the name of the tag is project and the value is prod. Okay, so what we are now saying is that we want to run this function against the servers or against the EC2 instances that have a tag with a name of project and a value of prod. Quickly save that test event and run the test. And there you have it. We've just run another test, and this time it's gone ahead and picked up the value of prod from the tags to say, okay, this is the one that it's going to work on. And it's come back with an EC2 instance that it has stopped. Is it the right instance it stopped? Let's check. So go back to the instance management console. Let's just quickly refresh that page. There we are. Our prod server is stopping. Fantastic. Okay, let's go ahead and start up these servers again. Okay, and we're going to move on to the fourth step of our how-to guide. We're going to look at how we can integrate EventBridge in order to schedule our start and stop events. So I'm going to go into EventBridge, just open that up in another browser tab. Just bring that over here. Okay, so EventBridge is basically an amazing service to help you build your serverless and event-driven application. Okay, it makes it really easy to build event-driven applications at scale using events generated in your applications, SaaS-based products, and AWS services. Now, we have an entire section coming up where we'll deep dive into how EventBridge works, but for the purposes of this lab, I'm just going to skim through the key elements that you need to complete this how-to guide. So with EventBridge, what you need to do is create an event rule. So we're going to go ahead and click Create Rule and give it a name. So it's going to be EC2 Start Event. Okay, and the event bus is set to default, and the rule type needs to be a schedule rule type because we want to start our EC2 instances at a designated time of day. Okay, click Next. There are two types of schedule patterns that you can configure. One's a fine-grained schedule, which allows you to define a specific time on a specific day to run the event. And the other is a rate expression, where you say you want to run the event every 10 minutes or every 20 minutes. Okay. To set up your schedule, you need to set up what's known as a cron expression. Now, if you've not used one of these before, just click on the info and you can get more information about cron expressions there. Basically, it's a method to define your schedules. Okay. So if we look at this example over here, if we take the third one, for instance, under these specific columns, you would define certain parameters. So under minutes, it's got year 0, under hours 18, day of the month is a question, month is any month, and the day of the week is Monday to Friday of any year. This basically means that you want to run this event at 6 p.m. okay, every day, Monday to Friday of any year. Okay, so this allows you to define your schedule, and we're going to do something very similar with our event. So I'm going to go back to my EventBridge. So my minutes are going to be 0, my hours are going to be 8. I'm going to put a question mark in day of the month. The month is any month. The day of the week is going to be Monday to Friday, and the year well, any year. And this gives us the next 10 trigger dates. Okay, and this matches up with what exactly I'm looking for. I want to run the start event Monday to Friday at 8 a.m. Click next. You then need to define what's the target of your event. Okay, so your target can be any of this stuff. Okay, it could be an SNS topic, an SQS queue. We're interested in a Lambda function. So we're going to trigger our Lambda EC2 start stop function to be triggered by this event. Now, you remember that our Lambda function can do more than one thing. Okay, it can start and stop our EC2 instances. So we need to tell our Lambda function what to do. And we need to pass that parameter specifically to start our EC2 instances to the Lambda function. So if you click on additional settings, you've got configure target input. Drop that down and select constant JSON text. So we're going to pass a piece of JSON text to our Lambda function to say, hey, we want you to run this Lambda function, but we only want you to run the start action. Okay, and that's where we'll add the start action. So there it is. So action is equal to start. And then we click next again. You can add tags if you wish. And next again. And finally create the rule. Okay, so that's our EC2 start event. Let's go ahead and create the stop event. So click create rule, EC2 stop event. Okay, and again, it's a scheduled event. Next. This time, I want to stop my EC2 instances at 2100 hours, 9 p.m. at night. And the reason for doing that, I'm thinking, is maybe because a few of my task users want to work a little bit late. You know, they want to get the job done. Perfect. So let's give them some room for that. Again, the day of the week is going to be Monday to Friday, and that's any year for now. And so the next trigger is going to happen Thursday, 4th of August at 2100 hours. Click next. Again, the same target. So it's our Lambda function that we're going to trigger. And the function itself is Lambda EC2 start stop function. And we need to do the same thing again. We need to pass a piece of JSON to tell the Lambda function what to do. So this time, I'm going to change this to stop. Okay. And obviously, if you are targeting a different set of EC2 instances with a different tag, you can add that tag in this JSON so that the Lambda function goes and triggers the start or the stop event against the other set of instances that you might wish to work on. Click next again, and click create rule. And that's it. My stop and start events have now been configured. EventBridge has now been configured with two rules. One to start my EC2 instances at 8 a.m. in the morning, Monday to Friday, and one to stop my EC2 instances at 9 p.m. Monday to Friday. Okay, so I'm going to pause the video over here, and later today we'll take a look at the actual stop event that took place. So I'll just pause the video for now. Okay, so let's go ahead and take a look at what actually happened. So my two rules still exist, obviously. And if I go to the EC2 instances, you will see that in fact my two test servers are in the stop state. So the next thing that we want to do is actually check how EventBridge triggered the Lambda function at the designated time. Now you will remember that when we were creating the policy for the Lambda function, the execution policy, we had also allowed Lambda to talk to CloudWatch to send log file informations to CloudWatch. So we can go into CloudWatch and check out those log files. So CloudWatch is a monitoring tool, and we'll be taking a look at CloudWatch in a lot more detail in an upcoming section in this course. But for now, I just want to show you how EventBridge and Lambda have essentially stopped the EC2 instances, and that information is available in CloudWatch. Now in CloudWatch, on the left-hand side, you've got logs, and there's a logs group section there. You will see that in fact there are a number of different log groups that I have. The one that we are interested in obviously is the Lambda EC2 start stop function. So if I open that up, there is a series of log streams available, and you'll see in fact there is the latest log stream, okay, which took place today based on the UTC time zone. This happened at 9 p.m. But essentially, if we go into it, you will see what actually took place. So you can see that the default tags was project is equal to UAT. Okay, two EC2 instances were identified with those tags. and subsequently they were stopped. Okay, so EventBridge triggered the Lambda function at the designated time, and Lambda went ahead and stopped those EC2 instances, and the evidence of that is in our log events within CloudWatch. And that's it. You've just used AWS Lambda and EventBridge to automatically start and stop your EC2 instances. And these combination of tools can help you automate a vast array of operational tasks that you might have for your business. Thank you.